Hi there and welcome to another video from Hegarty Maths. It's a GCSE revision video on solving simultaneous equations. It's my first one on this topic. I'm going to go through some basic ways to solve these simultaneous equations, and in future video I will show you how they come up in a sort of geometrical type problems. As always, for more help with your studies, do check out the YouTube channel or the Twitter page. Right, to start with, let's get straight into some examples. Example 1. Solve the following simultaneous equations. 3x plus y is equal to 16 and x plus y is equal to 10. Now, the easiest way to solve a simultaneous equation is if you can make the coefficients, the number in front of either the x or the y, the same in both equations. Now, they are currently the same in both equations. There is a hidden sort of 1 here, here and here, and we have 3 lots of x, 1 lot of y, 1 lot of x, 1 lot of y. The same number of y's in each equation, which is good, it's what we want. So to start with, tell the examiner what we're doing, label up our equations, equation 1 and equation 2. And if we subtracted these equations from each other, if I did equation 1, subtract equation 2, I would eliminate the y's and I could just solve for x. So put a line under it, keep it very neat how you do it, and tell yourself, remind yourself you're doing a subtraction. 3x subtract x is 2x, y subtract y is no y's, and 16 subtract 10 is 6. So we know 2x is equal to 6, so we divide both sides by 2, x must be equal to 3. Now, when you're solving a simultaneous equation, you must find the x and the y. So we've got the x, we find the y by substituting in either one of these equations, whichever we think is easiest. So subbing back in 2, so sub in 2, we would have 3, replace x by 3, 3 plus y is 10, so y must be 10 minus 3, which is 7. So then state our final answer, x is 3 and y is equal to 7, and underline your work. Now, at this stage, let's check it's true. 3 times 3 would be 9, 9 add 7 is 16, that would hold. 3 plus 7 is indeed 10. Now, before I go on, I just want to talk about the geometry of this. What does this mean? Now, these two are straight lines, and I'm going to go to Desmos and show you what they look like. So I'm going to go to a piece of software online which is called Desmos, and I'm going to draw myself the graph. We're drawing the graph 3x plus y is 16. So 3x plus y is equal to 16. And it looks something like that. Okay, and we'll also draw the graph x plus y is equal to 10. So next one, draw the graph x plus y is equal to 10. And that's that graph there. Now we can see these two cross at this point here, and we can ask the software to highlight this point for us here. So this point here is at 3, 7. X is 3, y is equal to 7. It's where the two lines cross each other. Now looking at this, how could I have got myself these straight lines here? Well, I could have made x be 0. If x is 0, y must be 10. So the line goes through 0, 10. And I could have plotted that point. If y is 0, if I made that 0, x would be 10. So it must go through 10, 0. I could have drawn a straight line. And I could have done the same thing up here. If x is 0, y would be 16. So I'd have the point 0, 16. And alternatively, if y is 0, then 3 lots of x are equal to 16. And so x would be 16 over 3, which is 5 1/3, which is this point here. And I could have drawn the straight lines, and their intersections 3, 7, and my answer is x is 3, y is 7. Okay, next example. Example 2. Solve the following simultaneous equations. Now, first things first, label these equations 1 and 2. I would like the numbers, the coefficients, forgetting about the add or subtract, I would like one of the numbers to be the same. Now, how could I achieve that? Well, just notice, if I multiplied this whole equation by 2, I would have 4y. So let's do equation 1 multiplied by 2. Every term is multiplied by 2. I'd have 6x plus 4y is equal to 14. And let's write our equation 2 underneath as it was before. 5x subtract 4y is equal to 8. I'm going to now call these 3 and 4. Although this one's not changed, just for ease, just call them 3 and 4. Now, the numbers in front of the y's are the same. We've got a subtract here. This time, just thinking carefully, if we were to add the equations, if we add equation 4 and equation 3, the y's would disappear. So we're not subtracting this time, we're adding. So draw a line under them, tell yourself you're adding so you don't make a mistake. 6x plus 5y is 11x. 4y add negative 4y is 0. And 14 add 8 is equal to 22. Divide by 11 and you'll get x is therefore equal to 2. And we need to find y, so let's substitute back into one of them. Let's sub into, let's say, equation 3. So 6 times 2, we'd have 12 plus 4y is 14. Take away 12 from both sides, 4y is equal to 2. Divide by 4, y is 2 over 4, which is a half. So our solution is 2 a half. X is 2, y is equal to a half. Checking it works in here. 3 times 2 is 6. 2 times a half is 1. They add to 7. 5 times 2 is 10. 4 times a half is 2. 10 take away 2 is indeed 8. Let's just draw the picture again from Desmos. 3x plus 2y is 7. Just to see how it looks. So let's draw 3x plus 2y equals 7. And let's draw 5x subtract 4y is equal to 8. So 5x subtract 4y is equal to 8. And we can see they cross at 2 a half. That was our solution to the equation. Now, if we're using geometry, graphs to solve this, could we have drawn those graphs? Well, yes. Let's go to the first one here. If I'd let x be 0, then 2 y's were 7, so 1 y was 3.5, so it crosses at 0. So this line here, if x was 0, y would be 3.5, so it crosses at 0, 3.5. I could have plotted that. If y was 0, then 3x would be 7, so x would be 7 over 3, which is 2 and a third, which is there. So I could have drawn that straight line. And this one here, if x was equal to 0, negative 4y is 8, so y would be negative 2. So I could have drawn 0 against negative 2. And lastly, if y was 0, 5x would be equal to 8, so x would be 8 divided by 5, which would be 1.6. So it would go through that point, and I could have drawn a straight line, and they intersect at 2 and a half, which is the answer we've got. Okay, so I'm not going to draw the graphs anymore, but you get the idea that all of these represent a graph. I will just do the last 2 equations, and in those the algebra gets ever so slightly more tricky. So here's example 3. Solve the following simultaneous equation, and we have 4y subtract 3x is equal to 29, label that equation 1, and y is equal to 2x plus 11. Now there's a slightly different technique here. You notice we don't have it in the form some knots of y plus some knots of x or a number. This one looks a bit different. But y is the subject of this formula. So if we took this y, okay, this y here, and replaced it by 2x plus 11, I'd have an equation with just x's I could solve, and then I could find y. So this method is called substitution. So I'm going to substitute equation 2 in equation 1. And what would I get? So what I'm replacing this y here by 2x plus 11. So let's write that algebra down carefully. 4, and then we'd have brackets 2x plus 11, subtract 3x is equal to 29. Expand the brackets. 4 times 2x is 8x, plus 44, subtract 3x is 29. Let's combine x's. 8x subtract 3x is 5x, plus 44 is equal to 29. Therefore 5x must be 29, we're going to subtract 44 off both sides, is going to be 29 take away 44, which is going to be negative 15, and dividing by 5, I'm going to get x is equal to negative 3. Now, you should keep working down the page, I've run out of space. If x is negative 3, let's work out y. Let's sub x is negative 3 into equation 2 to work out y. Y is therefore 2 multiplied by negative 3 plus 11. Y would therefore be negative 6 plus 11, which is equal to 5. So our solution is negative 3, 5, and we should highlight that to the examiner. Let's double check it works. 4 times negative 3 is negative 12. 4 times 5 is 20, and 3x would be negative 9. So 20 subtract negative 9 is indeed 29. And this, does it solve this? Well, y is 5, and is this side 5? 2 times negative 3 is negative 6. Negative 6 plus 11 is indeed 5. I've got it. If I drew these two lines here, they would intersect at x is negative 3, y is 5. Example 4, the very last one here. Solve the following simultaneous equations. Now, it's not like the one before. It's a bit like examples 1 and 2. So I'd have to make the numbers for the x and the y the same. What's the easiest thing to do? Label both equations 1 and 2. Actually here I might need to modify both equations so they're the same. I know 2 and 3 go into 6, so I could multiply this one by 3, multiply this one by 2. What would I get? Every term must be multiplied by 3, remember. I would get 6x, and I would get subtract 9y is equal to 21, and I might call that equation 3. And this one, I would get 6x subtract 8y is equal to 20, equation 4. The x's are the same, so let's subtract them. Let's do equation 3 subtract equation 4. Now here is where your negative numbers comes really into play. You must be careful here. Let's write your subtract so you don't make a mistake. 6x take away 6x is no x. Negative 9y, I'm going to write it over here. Negative 9y subtract negative 8y. Okay, well that's negative 9y plus 8y, which is negative y. So this will give me negative y. And 21 take away 20 is 1. So divide both sides by minus 1. Y must be negative 1 then. So sub back in. Make sure you get this right here. It's very easy to go wrong with negatives. So sub y is negative 1 in, let's say, equation 1. 2x subtract 3 times negative 1 is 7. 2x, negative 3 times negative 1 is plus 3, is 7. 2x must be 4. Dividing by 2, x must be 2. Our solution is 2, negative 1. Let's check it's true. 2 times 2 is 4. And negative 3 times negative 1 is plus 3. They add 7. 3 times 2 is 6. 4 times negative 1 is negative 4. Subtract negative 4 will be plus 4. They add to 10. Indeed, I'm correct. So that's it for this video on simultaneous equations. Finally, just make sure you tune in for the next video where I actually show you how to set the equations up and solve them from a context, usually a geometric context they come up in the exam. Okay then, so that's it for now. Check it out and tune in next time.